Good afternoon and welcome to the Sustainable Materials Management Webinar Series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen and I'm the Program Manager for the Center and will serve as your moderator today. We would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series and Lisa Ruggiero of the National Recycling Coalition for providing technical support. Today's webinar will focus on the use of recycled chrome rubber in hot asphalt mix applications. Our presenter today is Mr. Greg Browse of New Enterprise Stone and Lime. Following Greg's presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you are experiencing technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And now I'd like to introduce our speaker, Greg Browse. Greg is the Process and Quality Manager of New Enterprise Stone and Lime, a subsidiary of Eastern Industries Mining Division based in Winfield, Pennsylvania. Greg has over 35 years experience in the production and control of hot mix asphalt, also known as HMA, and related products. His passion in experimenting and inventive ideology has led his team in designing numerous products and techniques to benefit the HMA industry. Among those efforts include countless projects utilizing ground tire rubber, or GTR, which has ultimately led to adoption of a specification for use in Pennsylvania, which is the main state of his company's operations. Other innovations by his team include a patented fatigue testing device, also known as FAT, a pre-placement acceptance technique called real-time voids, and a warm mix asphalt foam system called Smart Foam. And so I'm going to turn the program over to Greg.
All right. Well, it's a privilege to be here to present this little bit of knowledge I have. I'm kind of a recycling freak in our industry, and so that's kind of what's provided me the chance to be here today, I guess, because I'm an experimenter. But I'm sure there's more informed people probably listening right now than I am. But hopefully what I have for you is informative, and if there's any questions, of course, well, I guess we'll be entertaining questions when we're done.
Yes.
Okay. All right. I guess that's a pretty good introduction, probably better than what I am. My passion is what I'm told is my strong suit. I'm not a genius. I'm probably not even a very good manager, but I am a visionary. I'm a dreamer. And my gift, to be honest with you, is knowing and working with teams that can build things and make dreams come true, honestly. Most of my work that I'm passionate about is a dream to make a difference to help perfect design, production, and performance in blacktop pavements, bituminous pavements, flexible pavements, whatever you want to call them for today, or what we said as HMA. We're all talking about blacktop. Okay, blacktop is termed flexible because the glue that holds it together, asphalt from the bottom of the refining, never really hardens completely. Concrete pavements, conversely, are rigid pavements because they're stiff and they can't move. Both of these pavements are useful. They just have different applications. So I guess you might figure out that rubber fit, and you need clarification, or I can even present. I do a lot of presentations and I enjoy it. Don't hesitate to ask. All right. Asphalt rubber, let's get at it. We're here today to talk about a blend of asphalt and rubber. Asphalt, the stiff liquid component in blacktop that comes from the bottom of the barrel after crude oil is refined. And of course, ground tire rubber. The product that's left after driving leaves you with 4 pieces of rubber that need a home. The asphalt, in this case, asphalt rubber, is the glue which holds blacktop together. It's usually somewhere between 5 and 10% of the total mix. All right. Now I'm going to blow my and the company's horn just briefly because there's a couple of things I'm very passionate about that kind of tie in with the work we've done with rubber. I'm going to just scream through a couple of inventions and things that I'm proud of that our company's developed. At any rate, on the upper left is a system called real-time voids. It is a truly valuable system used in analyzing pavement in a real-time, right now, quality with a quality test that can single out substandard material before you even get it to the pavement. This has actually been used in some European countries, so we're particularly proud of that. On the upper right is a foaming system which we developed that allows the use of warm mix, which produces hot mix at lower temperatures. And it's good for the environment and the blacktop. We designed the blender, not the warm system concept. On the lower left is a rubber blending device, which obviously is what we developed and used for the asphalt rubber that we're here to talk about today. On the lower right is a fatigue test device we developed to analyze durability and rut resistance to pavements. On the upper left of this slide is a device we invented to measure consistency or uniformity in the pavement surface texture called macro texture. Helps determine segregation, other quality, that can be problems. Safety funnel, lower left, a sample thief. In the other lower quadrant is just a picture to depict unbelievable pile of process capability and other studies that we've worked with some universities and states, Penn State included, Rutgers, so forth, for the betterment of the industry. Our team that we have that I work with, truly what we are best at is turning a concept into a reality. And a lot of the people that I work with in universities and so forth love to work with us because what we do is stick the model into reality and then kind of hand it back over to be studied, finished product. Now I'm going to throw this is, like I said, this is a real crude, my own version of kind of like Asphalt 101. What's a pavement made of? Okay. Typical pavements are dense graded. As I mentioned, they're 5 to 10% of the mix is liquid. Aggregate and stone are about an even split of the other 90 to 95%. Dense graded mixes are designed to be just that. They're dense, meaning the particle matrix fits very tightly together and not much space in between. Gap graded mixes are about half the amount of sand. What they are, they just simply allow, there's more void space, so you can put a mastic in there or just have air voids. Open graded mixes, one step further, use about half again as much sand, and they're kind of just like larger aggregate stone particles, leaving lots of space in between. And this is just basically a picture showing on the left what a dense graded mix looks like from a saw cut, and on the bottom of that also what the stone matrix is in there. Next, east in the center, you see what a gap graded mix looks like, and finally an open graded. By and large, dense graded pavements are what you find, I'd say, across the United States pretty much. They're economical and versatile, partly because they're a tight integration of stone, and there's not a whole lot of room for asphalt. But if they're combined properly, the asphalt, which is the most expensive component, you can minimize the amount of that asphalt, or I'll call it glue, some call it binder, to hold it together. And the aggregate portion is basically a lot of the most of the surface courses are a sandstone or a gritty, abrasive stone to help with skid resistance, and just about any kind of sand can be used in there. All right, liquid asphalt, the fun part of this is basically the bottom of the barrel from refining. I like to liken refining kind of like pressure cooking. You get off the top is like gasoline, naphtha. The next lift down, you might get fuel oil, diesel oil. The next motor oil, maybe. Everything else possible, once that's all removed, the bottom of the scum barrel is asphalt. That's what we use in pavement. In the new mix, the mix that we're talking about today, we're blending 20% ground tire rubber with 80% asphalt. That could be as low as a 90-10 split. The asphalt, the stiff liquid that comes from the bottom of the barrel, and the ground tire rubber product, of course, left over after you've done using your tires. As a result, what we end up with is a really nifty asphalt rubber blend that's a far more flexible and durable liquid. It kind of looks, it's a nifty blend. It looks kind of like oatmeal my dad used to make us eat. It probably tastes better. In the past, PennDOT, at least, and our industries resisted using rubber and a lot of recyclables. For a lot of good reason. One was the Ice-T Act, which tried to stuff it down the industry's throat. And to be honest, the department, the industry, everybody put their gloves on, and rightfully so. Basically said, wow, like, don't cram tires down our throats. We don't make them. That was, it was logical that everybody resisted it. For me, an experimental freak, it really didn't matter because I just had a lot of fun playing with it. So all that resistance kind of left me as the lone guy out there playing with rubber, and kind of like being a doctor in the West. And I've been playing with rubber since early 90s. And to be honest, I have no failures, at least none that I know of. And I've had a lot of mistakes, and even my mistakes seem as though they've held up quite well. All right, in the past, the blending, although wet blending is what we're talking about today, which is actually the best way to do this. In the past, and most of my experience has been with dry rubber blending, and that because it was economical. To do wet blending takes an investment, a large investment into blending equipment, and nobody was really willing to stick their necks out and start placing large enough quantities of asphalt rubber to afford bringing in blending equipment. An example, you got to forgive me if I skip ahead as I digress. But one example is the one section of pavement that we did, looking at maybe a finished blacktop of, this is ballpark, say $60 a ton. Just the use of the blending equipment cost an extra $15 to $20 a ton. And it's huge to do the wet process. So therefore, for many years, we used it as a stone ingredient. But it has unbelievable value, rubber, that is, as a stone ingredient. All right, so why rubber? Why now? We need something to help with the infrastructure crisis that we're in. I don't know, actually I do know most of the states are in similar infrastructure, I'll say ill repair that we are in. As much as I hate to say it, it's not going to get better fast. One of the problems for our public is it's really a problem for on the political side also, because the public is not going to realize why the roads are falling apart. They're not going to want to understand the fact that we've not taken care of roads. And because the roads fall apart, they look so doggone good all the way down through until they're ready to fall apart. It's hard to justify spending money. I found it funny yesterday. My girlfriend was complaining about delays on a bridge deck that was placed about a year ago, and I explained to her, well, it's a concrete sealer they're putting on that, newly, what seemed like, hey, they just worked on it last year. I found it interesting. She said, oh, okay, I'm okay with that. And she went on to say, I'll quote her, I'm a firm believer that it's easier to maintain than it is to redo. I just thought, wow, could you take that a long way? At any rate, one of the problems is we have a lot of roads that are in no repair. And asphalt rubber is going to help. It's not going to fix everything because we got a lot of stuff that needs redo. There's no way I could give a presentation about what's been done here in these projects and in the state of Pennsylvania without stating at least these two people as heroes, at least definitely in this state. One of them, Scott Christie, is the Deputy Secretary, Highway Administration here, and he's been a catalyst, I believe, in making in allowing us to start the adoption of this. Sandy Tosca, lower left, fantastic, open-minded, progressive engineer in District 3, who's also extremely helpful and considerate and understanding of what it takes to get industry involved in some of these things we've resisted for so long. She's just awesome. Okay. All right. Here's a shot of the Fed's trailer on our property. I think they were parked on our property for just about an entire season. And we really didn't mind all the electricity and stuff they used. But seriously, there's a great report coming out. As far as it's not out yet. They tell me they're just a little slow to put their reports out. But I am told that they have nothing ill to report. Everything seems favorable. The performance testing they've done and stuff on this mix is very good. I just threw this up. A lot of these presentations I've given in the state of Pennsylvania alone, so I use MassDOT because they're close by. But I know there's a lot of other states in here, Texas. I don't know who all. I didn't look at the entire attendees, but there's a lot of states with a lot more experience in rubber pavement than I have. But just use this as an example of how this product's growing. We placed several projects in Pennsylvania. I-78 was the first project, a substantial size project, near Allentown, PA, about 30,000 tons, placed in 2012. Snyder County, SR-15, our company placed that project, and project is looking unbelievably good. We're going to place another 30,000 ton with a sister company, Valley Quarries near Gettysburg. We're just gearing up now to get that project underway. The project this is just some pictures of the project. If you're in Snyder County, Pennsylvania, you might notice this at the intersection of 11 and 15. Near the Susquehanna River Bridge near Sunbury. We paved this section from the bottom of the hill to the top of county line, all 4 lanes, and we also did the ramps on the other side of this Route 61 bridge, which takes a incredible truck pounding. It's going to be a real fun. It's going to be great to watch this. And like I said, this mix is absolutely impressive. This is just a look at what the difference in pavements might look like that I've discussed here. A gap graded pavement, which in this case is what we designed and used, and I feel is probably currently the most widely used asphalt rubber mix. It's as we said, it's a little more, it's a gap grade. It has more stone than it does sand, and it allows for room for the rubber in the mix. The center is a dense graded mix that has an SBS polymer. I'll just say plastic mix. It's definitely the most expensive mix of what we're looking at, these 3 mixes. And on the right is a standard dense graded pavement like we see across the United States. And here we're just taking a look at the liquid asphalt. 6422, these numbers are ratings that the Super Pave system has come up with. It's called a performance grading system. the numbers are actually temperature ranges. Originally, the system was based on temperature ranges. 6422 is typically age-old asphalt cement we've been using. The center is the polymer modified I was discussing. That's considerably more expensive, to the tune of, if we're looking at $500 to $600 a ton for a 6422, you can throw an extra $100 to $125 a liquid ton for the mix with the plastic asphalt in it. The asphalt rubber on the right is a blend of 6422 and rubber, as we said, anywhere between 80-20 and 90-10. And what you're looking at is the viscosity difference or the thickness comparison. These were just basically 20-gram drops of asphalt left sit at room temperature for a reasonable period of time, and you see kind of how far they spread out. All right, the asphalt rubber that we did on this project and the material that I'm here to talk to you about today is using a wet blending method. As I said, I have an unbelievable history of rubber and knowing the value of rubber. In there's many different attributes to what rubber can do for pavement. But the wet blending system, I've only outside the laboratory. Okay, I've only seen it in use for a couple years here, and it is by far the best way to apply it. I'm convinced. And it's like I said, in the past it was the most expensive, but hopefully what's going to happen here is the cost is going to decrease as the use increases. All right, in the asphalt rubber gap graded wearing that we're looking at, you can see the components here. The sand's been cut in half, so you can see it's about a 72-20 blend of stone and sand, and then the asphalt at a basically, not quite an 80-20 blend. You're looking at 6.7% liquid and 1.3% rubber blended together. As I mentioned, one of the other attributes of rubber is that it's an impenetrable air void. Its flexibility also allows it to push back, which when it's pounded by heavy truck traffic resists over-densification, or what ends up in rutting and flushing in our pavements. I'm sure you've seen rutting and flushing if you've driven anywhere in the United States. All right, so how did we blend this mix? We basically kind of happened into because we're experimenters, of course, we originally took this job on and we're going to hire an outside blender. And for variable reasons, and because of the faith afforded by the districts to allow us to work through the problems and design our own little mixing system, that's what we did here. We developed our own blending system, which will hopefully be the beginning of other people jumping on board and the cost of blending coming down. All right, basically this is just another picture of the blending unit we developed. This is the first one. The one we're developing, the one we're setting up for our Gettysburg project will just be the next step better. As you're an inventor, that's what happens. Before you're done with it the first time, you're recreating it. This guy here I'd have to mention is one of my best friends who nearly killed me during this project. One of our IT guys who's just an absolute genius. These are the kind of guys that facilitate doing fun experimenting like this. I mean, these guys just step out there. I just can't give them enough credit. We pull something out and we say, hey, this might be good. And these guys just roll up their sleeves and go at it. Okay. It's just some more of the guys who helped throw this together, or look at some of the automation we have. And on the lower right, night shift pave, dropping some rubber in the bin. I call this more advanced testing. This picture kind of shows the difference between how thick this liquid gets when you blend it with rubber. Of course, on the upper left-hand side there is a bucket that was drained out of the line as we were blending. We kind of dumped the buckets on the side over an area so that we can reclaim the asphalt. There you can see how the standard asphalt on the right drained out of the bucket. Those buckets were placed there at the same time. As I said, asphalt rubber on the left, regular liquid asphalt 6422 on the right. Here's the same picture looking at the viscosity of the liquids, and here I've thrown together the cost, as I was mentioning, cost of a liquid ton. Standard asphalt, say $550, polymer modified 7622 at $675, and the asphalt rubber coming in at 25 bucks cheaper than the standard. Now, that's without blending costs. As you can see here on the below on the bottom, 800 bucks a liquid ton. If you're blending 10,000 tons, it drops down to 725 bucks at 30,000 tons. But like Scott Christie said when I first presented this to the PennDOT, he said those blending costs will go away, and he's correct. So the more we use it, pretty soon the cost of blending will just be part of our regular equipment. That's what's great about where we're headed. This is kind of a fun picture I have to share. This is a picture of, actually, I originally made sheets of the different liquids so that when I did these kind of pony shows like we're doing today, except usually I do them in person, I'd have little samples to hand out. What happened was that my technicians in the Lewisburg plant, I had them make sheets of these, and they were going to cut them up, and they had them stored in the freezer. And my son-in-law, who's the technician for me there, happened to drop a large specimen down in the freezer. And these guys were like, I could see when they came to me looking sheepish that something went wrong, and they were like, "Oh my God, Anthony dropped a specimen and shattered everything." The interesting part of this was the asphalt rubber didn't break, and so of course that spawned a whole series of experiments I did next. But what you're looking at is 6422, a 30-gram specimen. I believe they were 30-gram specimens. These were all like size specimens. And I used a test hammer that we use in the laboratory. I dropped one drop. These were cooled to, I think, 35 degrees, 35 to 38, all the same temperature. One drop on the 6422, you can see how far it shattered. 7622, the more expensive, you can see it didn't break down quite as much. 10 drops of the hammer on that asphalt rubber absolutely blew me away. That the stuff, I realized then the value, especially in the state of Pennsylvania, when we look at thermal cracking, the freeze-thaw cycling we have. Anybody who's looked at pavements, like, of course, I've looked at pavements too much, but thermal cracking happens no matter what kind of pavement you have. Of course, concrete cracks much quicker. That's why we have these slabs, and that's why we purposely put cracks in concrete because it's going to break. Same thing with asphalt, except the forgiveness of asphalt is what's kind of great about it. The cracks that can occur in asphalt can kind of like self-heal. But there you can see what will happen in the frigid conditions. This stuff's not going to crack. I mean, it's fascinating. An SMA is an increase, is a product that we use that's a high-end, very expensive stone mastic asphalt that we use for pavements when we need them to last longer and be more resistant to rutting. Or we use it on high-end, extremely high traffic roads. It costs a lot more money, but guess what? When you put it down, it lasts longer, and it doesn't take long until that cost is offset. Uh, Here's just an example of something I'm sure we see across the United States. But these are deteriorated pavements, and like I said before, the sad thing is the motoring public, you don't see these, you don't see the upper portion there. You drive over it, but nobody really notices the cracks until it starts to get to the point where it'll break your axle. Which in Pennsylvania, we're seeing these kind of devastating potholes on our interstates. I mean, and it's really not anybody's fault. It's just kind of happened. Here you can see this rutted pavement on the bottom right is actually a pavement that was placed only about 4 years ago, and it is with the extremely expensive high-end polymer modified. But when you put it on under some of the conditions, the stress conditions we have on the high traffic roads, it's tough on it. Go ahead. This I found interesting. This was an incredible story, and not far from where I live. Breaking news, they said, oh my God, this pavement's falling apart after only 2 years. It was like they were looking to see what the mystery was. But as soon as I saw it, it wasn't amazing to me. And one of the points I tried to make to at least the local people there and our local news media is it's kind of like my girlfriend had alluded to. If you don't maintain them, they're going to need redone. What I said about this was you can't put something on top of nothing and expect to have anything. They put a thin surface coat down on a road that's just absolutely destroyed. And so, it's going to be hard to keep these roads alive without spending a lot of money. This is just a kind of a slide where I'm expressing the same thing I've already talked about, and that is, there's things micro seal. Some of our people use, some of the DOTs are using this micro seal. All it does is extend. It gives you another 2-3 years until you have to do work on a road, but it's better than letting it completely fall apart. That's why we see these kind of crappy looking seal surfaces that they put down, and you wonder, you see them start to break up in a couple of years. It's just because there's nothing underneath. Okay, go ahead. This is just a picture of the ramp area on the Sunbury side of the bridge that I was talking about, and I just wanted to show this because you can see this is kind of deterioration we're talking about. This is basically what we paved over. That's why it's going to be exciting to watch this. I mean, this material that we placed is unbelievably durable. I've boasted that if this stuff doesn't last, I'm gonna retire, and which I probably should anyways. But nonetheless, I'll honestly tell you that this mix is the first mix in 35 years that I can honestly tell you that I would choose to warrant. At any rate, here's a look at the project on I-78 east of Harrisburg. Our company didn't place this. We just missed the bid. But by and large, it looks like it's really performing well, even though we didn't put it down. Here's a picture before I did one of the first, again, I call them pony shows, for the PAPA conference in Harrisburg. I thought I better drive down and see what this pavement's looking like, at least the first pavement. As I said, this is the I-78 project. Now, understand this, again, like I'm talking about, you can't put something on top of nothing and get anything. Well, this pavement was placed on a severely deteriorated concrete roadway. Slab shifting, very ugly chunk of pavement. So when I first came across, I thought, well, it doesn't look too bad. And in some of the areas I looked at, you can see here there's longitudinal cracking that occurs, of course, when we do these what we call mill and fills. There's an offset there that happens from that mill and fill, and sometimes there's a shear that happens there. So I wasn't blown away by that longitudinal crack, but the further I went down the road, the worse it started to get, and I kind of panicked when I came across. Like I say, as the further I went, the uglier it got. until I got to this point where these patches were reflecting directly up through. I was really upset because I thought, man, I've been boasting this, and I guess I am gonna have to retire now. But what's really interesting, if you take a look, you can see across the first lane, the crack stops. Well, what I ended up finding out was that this cracked portion is in the control strip area that was actually not asphalt rubber. It's the expensive plastic polymer modified mix that you're seeing cracked up. I mean, I didn't want to see a cracked up pavement, but very, very interesting to look at how this asphalt rubber is, I mean, well outperforming an extremely more expensive mix. I mean, it's impressive. Gives me goosebumps. Pretty sad, huh? At any rate, so this is just a picture I took. Actually, this was like Washington State. I went with my girlfriend, but I'm just trying to express that there's a lot of ugly, I mean, across the United States, there's a lot of temperature changes, which can be tough, but Pennsylvania's freeze-thaw cycling is just absolutely one of the most wicked in the United States. But there are all kind of other tortures out there, especially when you go south, you know, when you go hit Arizona, California south, Texas. I mean, unbelievable high temperatures. The neat thing about asphalt rubber is it is extremely resistant to flushing and to rutting, as I said, and to thermal cracking. This picture I just took is interesting. This was running when I was first experimenting around, looking at the gravity of rubber itself. One of the reasons pavements, you know, the asphalt itself can migrate, and when the density, when the material is densified, the liquid asphalt is the lighter gravity. Stone is gravity of about 3. Asphalt's a gravity of about 1. So the asphalt's naturally going to float to the top. The neat thing is when you put this particle of asphalt, of rubber in, the rubber's gravity is also 1. So it kind of like shoulder to shoulder says to the asphalt, hey man, stay down here. Kind of resists the flushing. Not kind of, extremely resists flushing. I've put unbelievable amounts of asphalt down and asphalt rubber in pavements, and I have yet to see one flush. Actually, I have yet to see one rut. So I know I'm setting myself up. This is just a picture of some of the more open, porous spots. There's always on the left, there's always a chunk of pavement where you can't quite get in there with a roller and so forth. But I'm here to tell you, I defy this mix to fall apart. I mean, it is just unbelievably durable. Part of it's because there's so much film thickness with this asphalt rubber blend. On the right, I can't help but experiment. As I said, as soon as I made some wet blend, before the job was over, I had to switch over and try to make a real thin film mix, and which we did quite successfully. And of course, we, you know, placed it somewhere where we probably shouldn't have, but I'm sure it's going to last. This is just, I threw this in here. Some of the states, I'm sure, are adopting to put this asphalt rubber blend in dense graded mixes. The universal mixes that we talked about, that I was expressing originally here, which don't necessarily, the asphalt doesn't quite fit inside the matrix. So when you go to using a dense grade mix, you kind of should look at a finer grade rubber, maybe even terminal blend, not necessarily. But one of the other things that I like to express here that we have to be careful about is when we look at rubber blended with asphalt, it's not 1-to-1. You can't take a 6% asphalt plus 1% rubber does not equal 7% liquid. I'm going to say it equals about 6.5. That might even be kind. But it doesn't, you know, it's still by and large, even with the excess of rubber in there, it's still cost effective. It's still cheaper in the end. Like I said, as we move to getting rid of the blending cost. And I'm thinking that about covers it.
Okay, thank you, Greg. Very excellent presentation. I can tell you're very passionate about this this subject. So we're now going to field some questions from the audience. Again, if you have a question, please use the GoToWebinar dialog box on your control panel. And if you give me a second here, I'm going to go to the question section, and we don't have any questions. So I'll give a couple minutes, and you can go ahead and type in if you want.
I'm really extremely boring or extremely thorough. I'll just make believe I'm thorough. Thanks for listening.
Yes, and like I said, the webinar is being recorded. After I edit it, I post it on YouTube video, and that will be made available as a link on the National Recycling Coalition and RMC websites. Here's a question. Maybe Greg, you might know this. Is there anybody in Tennessee doing rubber asphalt?
You know, I spoke with a lot of people in a lot of states, so I'm just, you know, off the top of my head, I do believe I was speaking to some people in Tennessee. Some actually, I think there were contractors there, not DOT folks, that were using rubber. I believe so.
Yeah, and this question is they're asking if you're still in the testing phase. I don't think you are at this point. I think PennDOT is moving forward with allowing this in their projects.
Yeah, right. Yes.
I'm sorry. Well, I'm sorry. And the question is coming from Michigan, who claims they have some of the worst roads in the country.
All right, I want to challenge that. But no, we have, yeah, Pennsylvania is adopting specifications right now. They're not, I believe we're completely out of testing phase. Now, we also have to be careful how we adopt. That's one of the critical things. We don't want to blow what we've already found out to be such a value. So we have to be careful when we adopt it, like anything, that we don't put it out there and have a lot of mistakes made because of the way that it's specified. And it appears as though they're going to take extra care and do it properly. Dense graded mixes are one of the things I fear the most. You have to be very careful. And in a dense grade mix, you have to take design precautions to make sure there's room for the rubber in the mix.
Okay, this next one's more of a comment. It's has to do with recycling of tires, and the cost of recycling keeps going up. And I guess the comment is how that relates to using this in PennDOT projects. Will the cost of the rubber go up?
I'd say the cost will go up of the recycled rubber itself. It's been one of my fears, and I've, of course, honestly, I'm an advocate for this mix. We don't really have anything to gain monetarily from either side of it. One of my concerns before we invested a lot of time and effort into it was my fear of just that rubber would go up. I think it might go up somewhat as the demand is there, but it's only going to go so far until other products keep it in check, like the polymer modifieds. And, you know, somebody's always going to come in there knocking. But I don't look for it to go up a lot.
Yeah, I know in Pennsylvania, we had a huge problem with piles of tires. I think 30 million at one point were stockpiled across the Commonwealth, and through a program, those piles were cleaned up, and developing markets for those tires occurred. And this is just one of those markets of using tires in transportation applications. This question has to do with using asphalt rubber mix in tropical countries. What are your thoughts, Greg?
My thoughts are I need to go there to look it over first. But no, there's no question about it, man. This is one of the powerful things, maybe I didn't express that clearly, but when you look at, there's several things, and, the fact that the rubber in that liquid is flexible allows it the ability, like I said, in the cold climates, but it also gives it the ability to spring back and keep the pavement from rutting, which is it happens quickly
as soon as the temperatures, maybe when you get up in the 90 degree, when you're 90 degrees Fahrenheit, a pavement can be up to 140 degrees because of the black color of the pavement real quick. So yeah, the answer is, I'd say it's as valuable or even more valuable in a tropical situation.
This question, they're asking you to review the costs again of the rubber mix.
Okay. Well, what I was...
Can we go back to that?
I guess you could, yeah. Because just feedback there, and it's not too far back. Again, even when you're looking at, that's where a good one, where that question was on how quickly the cost of rubber is going to go up. I'm not sure you didn't pass. Rubber itself is cheaper than the liquid. And actually right there, whoops, back up. Past it. I saw it. There you go. As you can see that the liquid itself is costing $550 for a liquid ton. When you add the rubber to it, I believe this cost evaluation here was at 16%. You can see the price actually came down $25. So the rubber itself costs less. So the blend, it's going to be expensive when it's first adopted, but it's not going to last long, and that's because of the blending fee. That's what you're looking at in this slide on the lower right, is what it costs per liquid ton if you're adding the blending cost. But that's going away. It's already gone for us, for at least for one of our plants.
Not sure if you can answer this, Greg, but this question asks, how does the asphalt lobby view this work? Don't they want to sell more asphalt?
I find that very interesting. I always stick my face in and think that, I'm always looking out for political, or, it always feels like somebody else other than a simple guy like myself has got their fingers in someone's pocket or something. I really don't think this is going to be that critical. And I thought the same thing about the polymer modifieds, but I don't think they're making a lot of money. I think the polymers cost what they cost, and I think there's a lot of use for those polymers. I really don't think anybody's going to make big waves about it.
This question asks, so do you go to the States, or do the States come to you? I guess this is a question of outreach and spreading the word.
As far as you're talking about me personally,
yeah.
Like I said, I'm open. If you're talking tropical, I'm definitely open. No, I've gone otherwhere. I've gone out of state. Of people that have reached out to me, Alaska, and some other states. Like I said, I have some with the real-time void system. I actually had some contact in Italy and Germany. Some interesting stuff. So I'm a good hands-on guy, but I'll reach out there. My contact info is on there. We can figure something out. I truly believe in this asphalt rubber and some of the other systems we have, and can maybe help out. That's what we're looking to do.
Greg's allowed to visit other states, but he has to come back. I'll come get him. This question is to the how long does the rubber asphalt blend last compared to other blacktops?
I'm going to have to. I have no clue as far as. I just simply can't tell you exactly how much longer this is going to last. I can just tell you that it's going to be huge. I can tell you that because of the amount of time I have, as I said, in early 90s, I've put rubberized pavements down and had really no failures. But when it comes to looking at the durability, the longevity of the pavement, I've looked at a great increase in longevity with the dry blends. This liquid blend, what I've seen so far, knowing how long the liquid asphalt in a regular dense graded pavement lasts, I'm honestly going to have to guess that this material will have to last, and this is really off the hip, at least 20% maybe 40% longer. I'm holding back on that. I'm just truly an advocate. I can't imagine this stuff's going to fall apart. Like I said, I'm quitting. I already committed. If this stuff doesn't make it, I'm leaving. But it will.
This question deals with potential stormwater runoff and contamination with the tires. Has there been any studies or testing with regard to the tire material leaching or any other issues with stormwater?
Oh, no way. I'll tell you one I find interesting is the same thing happens. We do this. I certainly don't want to make light of anything environmental, but we do this. We look at things. Sometimes I know I've had guys say, "Oh my God, what about recycling? When you put it in your blacktop plant." Well, we put recycled asphalt pavement through the blacktop plant, and nobody thinks about the fact that realistically, once you get asphalt hot enough, it's kind of like fuel, and the rubber particles themselves actually would ignite long after the liquid asphalt would. So I don't look for that to be a problem. Another example I like to use is for many, many, many years, I think some are probably still in use, the asphalt supply companies, so that they wouldn't have asphalt runoff, would actually have large ponds that they would store asphalt in. And those ponds were actually nothing. There's nothing underneath those ponds other than the liquid asphalt itself. And the reason being, what you're looking at here is room temperature or higher on liquid asphalt. And so realistically, when you drop it in soil, it's not going to go very deep until it hits a temperature where it's seized up and is solid. So now I don't fear anything from it, really, environmentally at all.
This question has to do with sourcing of the tires. What is your local source, and how do you see the industry sourcing the material?
The local source, it's really not hard to access this product. The local, I worked for a long time with one of the local guys here, Mahongo Recycling. Their product is extremely refined. It's a really nice product, and he just keeps continuing to make it cleaner and cleaner. And the nice thing is he keeps doing real good stuff with our, he just gets better and better about recycling the steel that's in it, the fibers that's in it. I don't see source being a problem at all.
Okay. All right, I think that's all for the questions. They're very good questions. Thank you again to the audience for those questions. In closing, again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the NRC and the RMC websites. Thank you again for joining us, and we hope you'll join us for next month's webinar. And please visit our websites for any scheduling updates. And thank you, Greg, for the presentation.
Thank you.
All right, have a great day.